Precipitation reactions are a very important class of reactions in chemistry. For example, if we had solutions of silver nitrate and sodium chloride and mixed them, the result would be that we would form some solid silver chloride, because this is insoluble, and sodium nitrate in solution. The solid silver chloride would eventually settle to the bottom. I'm representing the solid silver chloride here, and sodium and nitrate ions would continue to remain in solution. This is a precipitation reaction. Solutions of two soluble salts being added together, and the result is a precipitation or a solid formed. The insoluble product, here the silver chloride, is called the precipitate, often designated PPT. The result is a cloudy solution. Eventually, given time, the solid will settle to the bottom. As the precipitation reaction proceeds, the ions are being removed from solution. So in this case, we see that there are no silver or chloride ions in solution. Instead, what is present is silver chloride solid. This is a relatively simple example. We will see examples where more than one precipitate forms. Now, to be able to predict precipitation reactions, we need to recognize that ions are like people. They may exhibit different personalities depending upon the company they keep. There are some ions that react the same regardless of who's around them. An example of this would be sodium and nitrate. They're always going to be dissolved in solution. Other ions act differently depending upon their company. The example here is silver plus ion. When silver plus ion is around a chloride ion, they come together and form a solid. When silver is around a nitrate ion, it remains in solution. So when we apply the solubility rules, we need to consider both general and specific solubility rules. These are the solubility rules that I've given to you in your notes. The ones in your textbook are written slightly differently, but they're entirely consistent with these. You'll notice that there'll be slight differences from textbook to textbook, but for the most part, they are entirely self-consistent. If we look at the rules, we see the first couple rules are things that are always soluble. Always soluble cations, always soluble anions. Then we have the special case rules. Anions that are generally soluble and have a few exceptions, cations that are generally soluble and they have a few exceptions. And then the last rule deals with anions that are generally insoluble with exceptions. We will test you on the application of these solubility rules. You'll need to be able to look at an ionic compound and determine whether it's soluble or insoluble. Let's practice some examples. Potassium chloride. Potassium's a 1A metal. All 1A metals are always soluble. There are no exceptions. So potassium chloride is going to be soluble. Sodium hydroxide, soluble. A salt containing a 1A metal. Barium sulfate. Barium's a 2A metal, not always soluble. So let's look further. Sulfate compounds are generally soluble, except when they're partnered with these metals here. We see barium is one of these metals that when partnered with sulfate forms an insoluble salt. Barium sulfate is insoluble. Sodium sulfate, soluble, a 1A metal salt. Same is true for sodium carbonate. For 1A metals and ammonium ions, it doesn't matter what the anion is. These compounds are always soluble. The last example is iron hydroxide. Most hydroxides are insoluble. The only exceptions are those with 1A metals. So this is insoluble. Now we've practiced a handful of these. You need to do lots and lots of these because this is the starting point of many problems.